talk about computer systems, basically we mean by the hardware, the software, the user, and the procedure. Always try to keep all these four components in your mind. Okay. We always say that if you have a hardware but you don't have an operating system installed, obviously you can't utilize the hardware. And if you have the hardware and the software and you don't have a user, again, no one will be there to use the system. And even if you have the user and the hardware and the software, but the user does not know the procedures how to operate the system is not complete. We will discuss all the points today, inshallah. Okay, so we will be giving an overview of many types of computing environments to explore different types of operating systems, major components of operating systems, and obviously describe the services that operating system will be performing. We'll discuss all this today. Okay, the structure as well. So like I just discussed with you right now, that as far as an operating system is concerned, obviously it consists of processors, main memory, secondary storage devices, primary storage devices, disk printers, various input and output devices, and all these are communicating, okay, with the hardware. So basically it's the operating system which is doing it. The other way that we always explain an operating system, and the definition of an operating system is that an operating system is an interface that helps to the user to communicate with the hardware. Remember, we've learned about the CLI interface, we've learned about the menu-driven interface, we've learned about the GUI, in which you have the WIMPs, the Windows icons, menus, and pointers. So we always call this an interface through which you can basically communicate. So I repeat again, an operating system is an interface that helps the user to interact with the hardware. So if you want to interact with the hard drive, if you want to save something on the hard drive, you need an operating system for that. There are various operating systems. You have Windows, you have Linux-based, you have Apple. Okay, so there's the various operating system in the world. Okay, so Windows is not the only one. You should know that. Right. Please, you can raise your hand, or you can just ask me whenever you want me to elaborate. Okay, that will make me stop. Right. So, like I said, an operating system is basically plays a role between the user and the hardware. The OS goals basically are to control, execute application programs. We will be discussing this again and again in detail today. Make the computer system convenient to use, obviously, ease of solving user problems. Solving user problems obviously means that installation of the different devices and all that. Okay. And when we categorize the users, we also talk about the front-end programmers who will be using the compilers and the interpreters. Again, compilers and interpreters will be directly interacting with the operating system. So we'll discuss that as well. Okay. The operating system will obviously have a built-in shell and kernel, and these two basically help the computer hardware to efficiently work with the operating system. So where does an operating system basically fit in? Let's have a look. Now, you are the user, you're using the web browser, you're using email, whatever you're using, okay? There's this user interface program, okay? And then you have the operating system. Operating system, basically, you can see, is directly in touch with the hardware. Now, the hardware basically is the machine code. The operating system basically needs to convert your assembly language into machine code, okay? And this basically is done with the help of kernel. But frankly, it's not the kernel, it's the shell which is inside the kernel that does that. I repeat again, the shell will be converting the assembly language into machine language, because obviously we have to convert it into a language that humans can understand if you're using programming language. We'll discuss about kernel and shell again. Just an overview that where is an operating system placed in entire of this. So, well, that's the OS jobs which we'll be discussing today, from the memory management, process management. So the reason why I have it over here, so that during the exam you can remember the key points. So if you have the key points in your mind, you can easily answer the question, okay? So file management, device management, input-output management, secondary storage management, which means primary storage is your RAM and ROM, if you can remember, and secondary storage are your hard drive, okay? Where you permanently store data, okay? In your RAM, it doesn't get stored permanently. So, or in other words, primary storage, that storage which is there in the initial booting process of the computer. Secondary storage is there, where your data is permanently stored. All of you are with me, right? You can listen, right?
Yes, sir.
Okay, good. Okay, we will discuss about security, how the OS deals with the security, command interpretations and networking, communication management, job counting. We'll discuss all that. So services provided by an operating system. First of all, let's discuss the memory management. Well, memory management refers to the management of primary memory or main memory. Main memory is a large array of words or bytes where each word or byte has an address. So the most important thing is the last phrase, where each word or byte has its own address. So if every byte has an address, your operating system is helping you to get that particular address from that particular track on the hard drive. It commands the header, which is on the hard drive, to go and land at that particular sector and track to get that particular byte of information from there. Okay, so basically a hard drive's the head, which is basically on a lever, does not just randomly go there. It is just obeying command that is coming from somewhere, and this somewhere is the operating system doing it. Okay, and the operating system is doing it because the user tells us, but the user tells the operating system gives the command to the shell translates the assembly language into machine code, the kernel talks to the hardware, and the kernel does it. We'll discuss all that. Okay, so main memory provides fast storage to be accessed by the CPU. Okay, that's also another point. So an operating system does the following activities for the memory management. It keeps track of the primary memory. We just discussed it right now. Okay, so where the memory is stored. In multi-programming, the operating decides which process will get memory and how much. For example, if I'm working with MS Word right now, and when I open up Adobe Photoshop right now, and you know that Adobe Photoshop takes a lot of resources. It takes major part of your RAM. So your operating system will know that I really have to give a lot more space, more memory to the following application, because if I am unable to do it, obviously that application will not respond. Okay, and we will discuss this as well today, later on, that how is this allocation of memory is dealt with. So it allocates the memory when the processor requests to do so. Okay, it allocates the memory when a process requests to do so. Okay, when a process wants something to be done, your operating system will help locate the memory. And you will always see me mentioning this, that deallocates the memory, because this is the important thing about an operating system, that every time it will deallocate the memory when a process is no longer required. Because if it does not deallocate the memory, then obviously your buffer, your RAM, your cache RAM's space will always be filled up. It has to be terminated. It has to be deallocated. Because if I do not do that, what will eventually happen? Photoshop takes around, like, let's say 1.5 GB of my RAM. What will happen eventually? Okay, so it's very important that my operating system does that. It deallocates. Processor management. The processor management basically means what? The OS, the operating system decides which process gets the processor when and for how much time. This function basically is known as your process scheduling, and this is a very important thing, what process scheduling is. So an operating system will be there to decide that which particular process has to have how much time. Okay, so it keeps tracks of the processor and then the status of the process. Okay, this particular thing where this happens is also known as traffic controller. Obviously, it's just like the normal traffic that goes on in our physical life. If we are unable to control the data, where is coming from, and how much data is waiting, and how much has to be processed. So this is really important. The operating system needs to finish all the jobs which are retained there within the CPU, so that the CPU can efficiently work. Okay, allocates the processor CPU to process, and deallocates processor when a process no longer required. See, again, deallocates. It will again deallocate a processor when a process no longer required. So it has to do it. Okay, fine. When a job is not required, it's okay, fine. It's no longer required. It's not in your list. You're not supposed to do it. So it will deallocate it. Device management. Obviously, you know by the term what it means. So operating system manages device communication. Obviously, different respective drivers that you have. Keep track of all the devices. Program responsible for input-output control. Decides which process gets the device when and for how much time. Okay, any input-output device that you attach that needs to communicate. Let's say you attach 3 to 4 different devices. So your operating system will decide that which device needs how much time and for how long. Okay, this is usually very well done with multi-threading and multi-processing when you were playing games. Okay, allocates the device in an efficient way and deallocates devices. Again, see, it will always, when it allocates, it will always deallocate. When it starts a process, it will always deallocate the process. It will always do that, because if it does not do that, then obviously you will halt the processor. It will not be able to do its job any longer. So it's very important every time it does it. File management. Obviously, you know what file management is, which means we have to navigate through the directories and use the directories, files. How do we go through it? Okay, all this is done through the operating system. It keeps a track of the information, the location, the status, okay, in the file system, right? Decides who gets the resources, okay, who wants to get the access to the resources, and operating system will be doing that. Now, I don't want to like extend this to a lot more, but keep this in mind that there are different kinds of operating systems, okay? You also have a server-based operating system. Server-based operating system, for example, where Sir Khalid sits, he has the Windows Server operating system. If you take that into consideration, that particular operating system is doing a totally different job. Okay, so when we talk about decides who get the resources, this is on a particular workstation operating system, and this could be a job of a server machine as well, a server operating system. So first of all, you should know is that an operating system is just not an operating system. There are various kinds of operating systems, such as the Windows Server operating system has lots of different functionalities that is built to deal with multiple workstations. This is why it's used. Okay, right. Allocates the resources. Okay, what resources should be used, right? Okay, and deallocates the resources. Deallocates the resources. Other important activities. Well, there are lots of more, frankly speaking. We have the security, okay? Prevents unauthorized access to programs and data. Yes, this is not the job of only your firewalls and antivirus. Yes, it does not allow at times unauthorized access to programs and data. Can you give me an example of this, any one of you? How does it do it? I mean, like, it feels like I'm talking to myself for the past few minutes. Khatija, aap late kyun ho gaye, beta? Why were you late? Don't tell me I'm talking to myself. Hello? All of you can hear me, right?
Yes, sir.
Yes, sir.
Yes, Khatija, beta, Khatija, can you hear me, beta? Khatija? Can you hear me? No, Khatija can't hear me. Okay, security, like, because it's being recorded, I don't want to waste time. Let's read this again. Please be involved. I don't want you to cram. I want you to learn.
Excuse me, sir.
Yes बेटा बोलो. Yes Khatija बोलो.
सर मेरा
हाँ
लैपटॉप स्टक हो गया था इसलिए मैंने
अच्छा बेटा
और मैं लेट भी इस वजह से आई हूँ, सॉरी।
अच्छा समरी ये है कि वीबी इंस्टॉल नहीं कर सके हम मतलब हम आई हैव इट बस आप लोग नहीं कर सके. तो मैं वीबी की आज क्लास सेकंड वाली ऑब्वियसली विल नॉट डिस्कस इट. इंशाल्लाह स्कूल ओपन हो रहा है हफ्ते बाद, तो सैटरडे की क्लास जो हुआ करेगी उसमें वीबी स्टार्ट करेंगे. समरी ये बात एनीवे. So security के I'm talking about what do we mean by security? Like if we are talking about an operating system, if we are talking about different functionalities of an operating system, I just want you to think about it. Security के तल्लक operating system, I mean, we have an antivirus for that, we have an anti-malware for that, okay, we have a firewall for that, which is an external entity. But आपने नोट किया होगा कि whenever you install the latest versions of Windows 8 and 10 में है कि whenever you have to install something, it always says, do you want to install it or not? This is part of the operating system security. It prevents unauthorized access to programs and data. If you say, yes, I want to do it, it will help you to do so. So you might have seen it. अब जब install करोगे, तो वो कहेगा, yes, I want to install it, or no. Why? क्योंकि अगर आप Windows 7 से पहले की बात करते हैं, in fact पहले की भी नहीं, Windows 7 में this was not the case. Windows 7 में when you clicked on a setup, it will start installing. But now, the latest operating system that you have will always have a means by which you will be authorized to do it or not. Okay, could be password. हमारा password नहीं, हमारे पूछ लेते हैं. Okay, recording delays between request, control over systems performance. Okay, that's another thing that will be do. It will have a control over systems performance. It will make sure that the system performance keep on going on. If there are any delays in the request, and if there are some responses from the entire system that are being delayed, it will try to control over that. It will try to prioritize it. Those requests that are taking more memory and all that. Again, we are going to discuss this. Job accounting, keeping track of time and resources used by various jobs, and so it will keep a record of all that. Error detecting aids, production of dumps, traces, error messages, and other debugging. It's a built-in facility within the operating system that if something goes wrong, if there's an error, it usually comes in the beta version of the operating systems a lot, but when the final version is released, you will not find this much. So error detecting aids obviously helps the programmers to redevelop the system, redevelop the operating system for the next phases that might come in. So system development like cycle में आपने पढ़ा होगा, future developments may we always have is that any errors that were experienced in the previous version will be catered with in the next version. Coordinating between other softwares and users, obviously we'll be talking about compilers, interpreters, assemblers, and other softwares of various kind. So it will coordinate between all these as well. These are the other activities that you should keep in mind if a general question comes in. So if you generally look at, if you talk about your computer, it's in the very center. That's your operating system. So these are your applications, and this is your user. So your computer is directly in touch with the operating system, so the applications can be used by the user. So this is how basically the entire thing goes on. Static view of system components, you should also have a look at this. So you have a user might be using a compiler, assembler, text editor, database system, whatever the user is using. But the point is that application programs, operating systems, and that's your computer hardware. It's another view of how it can be described. Again, a dynamic view as well. Okay, I'll share this with you. You can have a look at it afterwards again. I want to come to, yeah, I think so. We did discuss virtual machine sometime in the previous lecture. Virtual machines. I did. Virtual machines basically are what? It's a very good concept. It's a very good concept that was developed in operating systems in which you could actually install two different operating systems on the same hardware. I did explain it before. So if you want to install two different operating systems on a hardware, it's very much possible. What you need to do is you have to create a virtual machine. A machine that does not exist physically, but you will split your computer in such a way that it will be divided into two different sections. So one of the operating system, we will deal with the with the hardware in a different way, but obviously it's not that you will be running both of them simultaneously. I did give you an example of virtual machine probably in the previous lecture, was the Internet Information System, where I did tell you that in order to upload a website, we always have to buy is an external domain. We have to host the website on a hosting server. I don't want to do that. I just want to make a local host server on my machine. So I will convert my own computer into a virtual machine, into a virtual hosting server, pretending that as if I have uploaded all this, pretending that I have uploaded all this on a remote server. I will do that all. In fact, I'll show you someday. Practically, मैं आपको करके भी दिखाऊंगा जब हमारे पास टाइम होगा. तो इसका फायदा ये होगा कि your computer will be working as a client and it will be working as a remote server as well. एक ही कंप्यूटर में. Okay, उसका तरीका होता है कि you just have to install IS और आप ब्राउजर में टाइप करते हैं localhost:// and then the URL. इससे होता है कि the URL जो आपने लिखा हुआ है वो आपके कंप्यूटर में डिफाइंड हुआ होता है. Well, we don't actually have to do it practically or वैसे पूछेंगे नहीं, मगर I will show you अब concept clear होगा. That's about virtual machines. We just talked about kernel, the importance of kernel in an operating system. It's very important. Kernel actually is very, very important. Kernel basically does all these processes for you. Okay, kernel काफी कुछ करता है आपके लिए. In fact, we should मेरे ख्याल से मैं डिस्कस नहीं किया हुआ. I can, all of you with me, ये मैं शेयर कर दूंगा आपके साथ बाद में, क्योंकि मैंने नोट डाउन नहीं किया, मगर आपको पता होना चाहिए what does kernel does. Okay, I'll just write in caps. Kernel की properties last time मैंने आपको TC की बताई थी. You should keep in mind what does kernel do. Kernel basically is quite important. Okay, basically it's known as it's the central core of the OS. We can say it's the central core of the OS. It's the most important component, or we can even say that is the nervous. It's the nervous system of the OS because it controls. That's why we always call the nervous. Okay, what does it do? Kernel basically will be doing the following things. It will be doing the process management. One of the most important things, it will be doing all this. It will be doing the device management. It will be doing the memory management. It will also be doing the input output communication. It will also be doing file system. Okay, file system handling. Yes, interrupt handling. By the way, interrupt handling, basic interrupt. I don't know, there's single R. Yeah, there's single R. Interrupt handling, obviously, you know what's meant by interrupt. When someone is talking, you start talking in between. You're interrupting the person. You're interrupting the conversation. यही काम होता है operating system भी handle करता है. It tries to handle the interrupt. Like for example, if there is any other program that tries to intervene in the middle and not let the previous application or program to do its job, so interrupts को वो handle करेगा. अभी हम इसको discuss करेंगे. So what is interrupt handling? So these are your points of the kernel. Okay, ये आपको वैसे पता ही चाहिए. Book में उन्होंने discuss नहीं किया होता detail में, but you should by the way know it. Okay, CLI is user OS interface. You know what CLI is. Okay. Discuss हुआ हुआ ये. Operating system structure, hardware, kernel, shell. मैंने अभी आपको explain किया था. This is where the user is. User is using different things, different applications. कंपाइलर जो भी है, फिर आपका शेल आता है. मैंने शेल आपको इसलिए बताया था कि शेल बेसिकली कन्वर्ट्स your high level language, your assembly language, and converts it into a language that kernel and hardware can understand. Okay, kernel will not get the assembly language. It will understand in the machine language so that it can communicate with the hardware. क्योंकि अगर आपने hardware से बात करनी है, you need is a machine language. So kernel को hardware की language समझ आती है. Shell convert करता है applications की language into kernel की language. So assembly language into machine language so that the communication goes on. So that's the operating system structure as far as the communication languages are concerned. Process scheduling, very important. One second. हमारा time तो नहीं end होने वाला. No, we have 4 minutes. Okay, we'll have to reconnect. Okay. The process scheduling, please इसको गौर से बेटा सुन लो. ये बड़ा important topic है. It's very very important. Process scheduling का obviously मतलब ये है कि your process manager that handles the removal of running process from the CPU and the selection of another process. How this goes on? कि कोई अगर अभी कोई process चल रहा है उसको remove करना है, फिर some other process को I have to enable it. All this has to be done. Okay, it's very important part of your multi-programming operating system, such as it will allow more than one process to be loaded into executable memory. Okay, so we will discuss all this. Process scheduling, what is it? A long-term or high-level schedule program controls the selection of the program stored on a disk to be moved into main memory. Occasionally, program has to be taken back to disk due to memory getting overcrowded. This is controlled by medium-term scheduler. When a program is installed, होता ये है कि at times the CPU will not be free. CPU के पास काफी ज़्यादा jobs होंगी. Process scheduling क्या करेगा? Process scheduler will schedule कि कौन सा process कब करना है, prioritize करना है, उसको slice करना है, क्या करना है, time allocate करना है, क्या करना है, उसको हमें discuss करते हैं अभी detail में. So process scheduling का मतलब यही है कि which process needs to be executed first, prioritize क्यों करना है, okay, ये किस तरह होगा. This is what we are going to discuss. So the components that will be involved in all this scheduling and running of program, obviously we know the disk है, memory और CPU. Memory दरमियान में आ रही है, ये ज़हन में रखना, and the communication between both of them is going simultaneously. Disk, memory, CPU, it's going on. ये ज़हन में रखना. So process state basically क्या होता है? Process state का मतलब obviously ये है कि the process is being executed. जब कोई process execute हो रहा होता है, तो उसको हम कहते हैं कि वो एक process state है. Okay, and as the process execute, it changes its state. कभी एक state से दूसरी state में जाएगा. The state of process is defined in part by current activity. Okay, so process control block. Process control block basically वो block होगा जब process store हुआ होगा. Okay, and it is basically stored there in the memory, ready to receive data when the process is executed. अब let's look at this. I hope ये time ना खत्म हो जाए, ये सबसे important चीज है. Each process may be in one of the following state. सबसे पहले आएगा आपका new. The process is being created. सबसे पहले let's say मैं कोई print job भेजता हूँ, मैं कोई भी process करता हूँ कंप्यूटर पे, so सबसे पहले एक process create होता है कि when I send a print job, तो एक process create हो गया, ठीक है? So new has been created. Running. The instructions are being executed. मैंने जो process है, running का मतलब ये है कि जो process है, अब वो execute हो रहा है. जो instruction मैंने दी थी, click की, control P की, now they are being executed. Fine, ठीक है. Waiting का मतलब है the process is waiting for some event to occur. So maybe obviously the processor at that particular time is busy. So the process has to wait. Okay. There has to be some waiting, and there always a waiting time. Always waiting time fetch execute cycle में जरूर होता है. So there will be waiting time where the process has to wait for the signal, okay, where it can actually go and execute. Okay. So ready. The process is waiting to be assigned to the processor. Waiting के बाद ready होता है कि fine, और जब वो ready हो जाता है और उसको allow होता है, then it's terminate. Terminate का मतलब है it has been executed, that it has been finished, that it has been done. Okay. मैं बेटा इसको I'm disconnecting. Please rejoin again. वो फिर ना connectivity नहीं रहती हम लोगों में. मैं इसको stop कर रहा हूँ. Join again. Let's continue. Here we go. So let's go ahead. Now look at this again. So what's happening over here is let's see how it goes. Why is it appearing at the minute? Okay, so you get a new process. Okay, I made good animation. Yeah, process is being created. You create a new process. That process is admitted. Okay, fine. We admitted means we say, okay, fine. Let's accept the process and let's continue processing the process. So the process gets ready for execution. That's what happens in this particular step. Once it's get ready for the execution, there is a scheduler dispatch, which means that when it's ready, it will dispatch the process and it will send it to the running stage. The running stage basically means that it's now ready to be executed, like explained previously. Okay, I just wanted to elaborate more. So now in the running stage, the process is being ready. It's ready to being executed because it's just waiting for the process to say, come, you can come. Okay, now let's execute it. So there could be a reason that your particular process does not get executed and does not exit and does not get terminated. Okay, if it does get terminated, excellent. You send a print command, it's done. It's done, but maybe at times it will not be done. The process might be complete. The process might not be complete. Let's say the process does not get executed. It might be due to some interrupt. Interrupt basically means that there was some other priority, there was some other process that came in and interrupted. Due to that, the processor could not do it. Okay, there are some prioritized preferences that are set up. Just say you were not able to handle it. So interrupt ने basically क्या किया? Interrupt ने उसको भेज दिया वापस. It went back to the ready. It will not like finish it. It will send it back to the ready. So the process gets again ready for execution, the same one, and waiting line में दोबारा हो जाएगा और running में. So obviously this cycle happens at times when you are unable to execute it. So waiting में भी जा सकता है. For example, input output में कोई event हुआ है, आपने वो किया है, आपने keyboard से कोई interrupt किया, आपने you clicked somewhere, so again it will go in the waiting, और फिर वही दोबारा ready में चला जाएगा. So ready में there could be interrupts from the hardware or from the software. The upper one that I'm showed you, it's probably within the software. The down one I'm showing you, it's within the hardware. Hardware कैसे भी interrupt हो सकते हैं. Interrupt can also be with the software. But whenever there is an interrupt, your running state goes back to the ready state so that it can again be in the timeline so that it could be executed and terminated in a much more proper way. So you should be, you should have all this cycle in your mind. This diagram is also there in the book as well. You can even have a look at that one as well, like I said. So interrupt can happen in the software because there are some other processes which have much more high priority, like I said, and the process needs some sort of event for it to occur. Interrupts. So interrupts are signals sent to the CPU by external devices, normally input-output devices. Okay, they tell the CPU to stop its activities and execute the appropriate part of an operating system. So interrupt, obviously, is trying to do its job. Ab darmiyan mein kehte, no, you do my job first. Okay, interrupting. But we cannot ignore the interrupts because sometimes interrupts are really important to be handled as well. There are three common types of interrupts that you should be aware of. One is hardware interrupt. Okay, hardware interrupt, obviously, hardware devices to signal that they need to. They may have just received some keystrokes, okay, or some other data on the Ethernet card, okay, through the internet. So these interrupts have to be handled. ये hardware interrupts हैं. Hardware के through जब होगा उसको hardware interrupts कहते हैं. Software interrupts are generated by programs when they want to request a system call to be performed by an operating system. Okay, so कहीं भी अगर किसी program को हमने कोई priority रखी होगी, it is taking more memory, so the software needs more time. So obviously that will interrupt and it will be given the priority. Then you have traps. Traps are basically they're generated by CPU itself to indicate that some error or condition. कोई interrupt ऐसे भी होंगे that have to be dealt by their own. They are intentionally done. What I mean to say is, okay, that's why we call them traps. They're generated by the CPU itself. इसको trap का word इसलिए कहा गया है कि CPU ने कोई error देखा है अब और CPU कहता है कि fine, I'm not going to like cater for this. Okay, so I'm going to create an interrupt, which means there's some error or there's a condition that probably I'm not going to fulfill. So I'll put it in a trap. तो वो उसको fulfill नहीं करेगा, वो traps में आता है. So there's hardware, there is software, और फिर there are traps जो CPU खुद ही generate करता है, CPU does it. Scheduling algorithms की बात करते हैं, there are two. There is preemptive and there is no preemptive algorithms. Obviously, a preemptive can halt a process that would otherwise continue running undisturbed. If an algorithm is preemptive, it may involve prioritizing process. Listen to this again. I'm sorry, this chapter is lengthy, और मेरे लिए ये chapter आज खत्म करना जरूरी है, and we have to speed up our process now. Let's finish this chapter today. So even if you're feeling sleepy, shake your head, okay, and order for a cup of tea. You can do it in बस ये लॉकडाउन क्लास में ये फायदा आप लोगों का, you can drink like the way I'm drinking tea. स्कूल में ऐसा नहीं हो सकेगा. Okay, are you with me, all of you? या मैं ही बोली जा रहा हूँ?
Yes, sir.
Good. So what is preemptive?
Yes, sir.
Good. Why do you feel like you're so sleepy? क्या हो? Come on, wake up. An algorithm is preemptive. Okay, it may involve prioritizing process. Okay, preemptive का मतलब है कि अगर उसमें prioritizing है ना तो उसको हम preemptive कहते हैं. अगर उसमें prioritizing नहीं है ना तो उसको हम non preemptive कहते हैं. प्लीज ये ध्यान में रखना. Prioritizing का मतलब obviously आपको पता है कि किसी को priority पहले अगर देनी है किसी process को तो हम उसको पहले देंगे, नहीं देनी तो नहीं है. मगर there is a very simple algorithm जो 3 decades back develop हो गया था. That was known as the first come first serve की basis में. Frankly, जो printout की मैं example आपको बार-बार दे रहा हूँ ना, वो है first come and first serve की basis में. जो पहले printout भेजेगा उसको पहले printout मिलेगा, जो बाद में भेजेगा उसको बाद में भेजेगा. यूं ही होता है लैब में, आपने नोट किया होगा. And that's the way it goes. There is always a spool that is maintained. उस spool में आप देखोगे कि 1 to 20 जो list है, it always is in the order of first come first serve की basis पे. So it will be very inefficient if it is the only algorithm employed but can be used as a part of more complex. मतलब ये कि first come first serve no doubt is a very good way, मगर it can become very inefficient अगर हम इससे अकेला इस पे सारा काम छोड़ देंगे. अगर हम scheduling of processes, if we create an algorithm and if we depend on the algorithm which is known as the first come and first serve algorithm, if we leave our entire CPU processing only on this algorithm, it's not a good way. Why? Because there are some softwares, there are many applications जिनको हमने priority देनी पड़ती है. We do have to. We'll talk about that. So first come first serve का queue अगर आप देखोगे, just look at Gantt chart down here. क्या हुआ कि मैंने burst time basically होता है when you execute it and you send it for termination. वो time होता है execution का. So you can see over here is if I have 24 milliseconds for P1, उसके बाद I will have is 3 more for P2 and I'll have 3 more. So this is how basically first come. पहले ये हुआ, फिर ये हुआ, फिर ये हुआ. Obviously एक normal sequence के तरीके में हो रहा है. Then the next is your round robin. Round robin method is very good as well. It's in this approach, the CPU scheduling, we have a fixed time. Am I recording the lecture? Yeah, I'm quite sure. We have a fixed time quantum and the CPU will allocate process. So we will have a fixed time. For example, if we have 3 processes going on, P1, P2, and P3, we will give 2 milliseconds for every process that we have, 2 to 2 seconds for all of them. So once the P1 is done, then 2 milliseconds is given to P2, then is given to P3. Okay, this is basically time sharing environment. Time sharing कहते हैं इसको कि time allocate किया जाएगा हर process को. Okay, इसमें and we also always say कि इसमें there will be no starvation of any process. Any process will not be starved to death. कि उसको by the word death, technically I don't mean death, but what I mean is कि it will not get redundant, ज़ाया नहीं हो जाएगा. It's known as round robin. Priority scheduling, obviously, का मतलब ये है third वाला. I think so. You did get it from the word. कि priority scheduling का मतलब ये है कि which schedule, which process needs to be given what priority. Okay. So किसको आपने ज़्यादा priority देनी है, किसको आपने कम priority देनी है. For example, if you can have 0 as the highest or 100 as the lowest, and this is what is done in the actual algorithm of the priority scheduling. आप priority देते हो, आपसे priority define कर देते हो, ठीक है. Example obviously यही है कि P1 की priority 1 है, P2 की second है, P3 की 1 है, P4 की 3 है. So obviously जिसको ज़्यादा priority दोगे वो पहले होगा, वो वरना दूसरा बाद में हो जाएगा. Virtual machines का I did talk about this before as well. मैं पहले बात कर चुका हूँ. Okay. Like I can share the video lecture with you again. मैंने share किया होगा. So virtual machines में you can have different virtual machines. Application and processes होते हैं आपके. Application processes, and your virtual machines. Virtual machine manager install करोगे and shared hardware. Shared hardware this is important. कि software end पे तो you have a different virtual machine, but hardware तो एक ही share हो रहा है, and this is the point. This is why we need is a virtual machine. Okay, कि हम एक ही hardware पे करें, we don't have to spend a lot. So the example that I've given you, one was of the internet-based system, internet information system. ये एक widely very general example है, और दूसरी मैंने आपको ये भी example दी थी कि एक ही अपने laptop पे, maybe you might have done it, कि आपने Mac पे Windows भी install की हुई हैं, and many people do it Mac पे. So उसके लिए you can create a virtual machine and you can do it through that way. एक virtual machine में आप install कर दो Windows operating system, और by default आपका Mac का ही होगा. So you can have both of them. You get the point? Yes, beta. All of you.
Yes, sir.
Yes,
Okay.
sir.
So this chapter is done for today. ठीक है. I'll stop for today. although हमारी एक क्लास नहीं आज हुई, वो अब वीबी का इंशाल्लाह नेक्स्ट वीक जब स्टार्ट होगा ही, हम जाके स्कूल में इसको स्टार्ट करेंगे. आपने एक काम करना, all of you. I want you to go through chapter 17, 19 and 20 that I've done today, and please make points and let me know कि sir we did the following मगर I did not get the following points. Can you do this now? मैंने आपको अभी तक कोई काम नहीं दिया जब से क्लास स्टार्ट हुई है. This is the first time I'm giving you work. So I'm asking you to write it down 17, 19 and 20. Go through it. Make your points. Make your notes, please. And let me know in the next class कि सर मुझे हमें ये point समझ नहीं है. Can we talk about it? जो हम कर रहे हैं at least वो हम अच्छी तरह कर लें so that we don't have to come back to it again and again. बाकी हमारे काम भी रहते हैं. हमने P4 भी start करने very soon as possible. I want कि हमारा soon दिसंबर तक तुम्हारा सिलेबस ऑब्वियस खत्म हो जाए. It has to, inshallah. Right, all of you got it? Any question?
No, sir.
Right. So please pull up your socks. मैं अभी कह रहा हूँ, अभी मेहनत करना शुरू कर दो. टाइम का आपको पता नहीं चलेगा. I'm telling you. You will not know कि ये months किस तरह गुजरे हैं. फिर आपको वो एग्जाम्स आ भी गए इतनी जल्दी. Right? I am taking your attendance. I've done that. तो राइट, सो इंशाल्लाह ट्यूसडे को मिलते हैं फिर. ठीक है? राइट गर्ल्स? ठीक है बेटा?
Yes,
I'll share the video lecture. I'll share the video lecture. दोनों को कंबाइन करके ना मैं आप लोगों से शेयर कर देता हूँ. ठीक है बेटा? ओके बेटा, टेक केयर. अल्लाह हाफिज.
Allah Hafiz.
sir.
अल्लाह हाफिज बेटा.